monster type we use, and 1,000 length with 1,200 wide. Yeah. In that type we use the standard type of our foreshadow. And then when the depth is the length of the palette is under 800, we need to raise our we need to raise our lift palette in the foreshadow. That means the height of our foreshadow goes to 180 millimeters. Our standard type of our foreshadow height is 150 millimeters. Yeah, from this form, when we meet different type of palette, we can make a quickly choose. Then we can also from the different weight of load can decide different type of our foreshadow. Basically, we just focus on the length first and find out the width of our shadow. Then we choose the weight of the cargo, so we can find out the type of our foreshadow. Okay, this is the robotics basic block. These models are used for our CAD layout. First one is our single storage location, and this is our main line, and this is our sub-line, and this is the model of our hoist. Also, we have a roller conveyor line and a transform machine chain conveyor line. Do you guys have a basic knowledge of this models? You know what is this? Maybe I can show a picture. This is our hoist, and in the hoist we have a chain conveyor. This chain conveyor is on our lifting platform, and this is our chain conveyor to do inbound and outbound work. And in front of our chain conveyor, there is a basic lift. This lift is for our similar like forklift, maybe. And this one is our roller conveyor. It's used for to transport our pallet to different direction. And then we go to this way. This way means we can use two different forklifts to connect to one our forklift. That is our efficiency of the lift. So this is the basic knowledge of this model. Okay, based on the basic function of the conveyor system, I think we have developed some special docking equipment to enhance the overall functionality of the warehouse system. First is our routing stage. I think from the name we can know what it is do. It's just to route our pallet. Same like if we want a pallet to go in different direction, or maybe a forklift just cannot change the direction of our pallet, we can use this system to do this work. And this one is a follow mounted lift. It's used for our handling fork. And this is stacking and this stacking destacking machine that is used for our empty pallet in the inbound and outbound work. When we do inbound work, maybe our forklift just transport our materials at inbound conveyor, and we need this machine to provide us a mother pallet. And when we have empty pallets, we also use this machine to do stack work, and maybe 9 to 12 empty per stack. And also we have a four-side webbing filling machine that's used in lots of food industry. That means we can provide a filling to stack our pallet. Okay, this is a basic plan to try a side view. First of all, we can change the length and the height of the pallet. Then we find out how to drive the rack system. Seems like we need a distance between our rack and our pallet is 75 millimeters. And basic on the rack system, we can find out the lift height. I can show how to do this work.
아니면 특정 셀을 지정을 해놓고 그 셀에다가 A 셀이 갖다 놓고 A 셔틀이 갖다 놓고 B 셔틀이 가져가고 무슨 제품 있어요. 얘가 여기 빼서 한 대다 옮겨야 돼. 얘가 여기서 여기까지 가게 넣어서 옮겨해야 되고 그러니까 얘가 특정 이제 중간 지점에서 만나서 이 셀에 있는 거를 이 팔레트를 A 팔레트 A 그 셔틀이 들고 와서 B 셔틀에다 옮기를 하든지 안 그러면 특정한 셀 지점을 해놓고 그 셀에다가 얘가 갖다 놓으면 얘가 다시 간다는 것도
셀로 놔둬서 옮기는 거는 가능한데 셔틀 대 셔틀 옮길 수는 없어요.
저기 프로그램 자체가 문집제거나 프로그램 내에서
그런 경우가 언제 필요할까?
저희가 하려고 하는 거는 그때도 말씀드렸지만 1층에다가 이거는 할 거예요. 예약을 딱 걸어서 내가 야간에 내일 아침에 나갈 거예요.
예비
딱
출고,
그거 나오는
예비
거예요.
출고하는
딱 그거 나오는 거예요. 그러면 그 특정 웨어를 선택한 다음에 거기는 내일 나갈 거면 다 저장이 되는 거예요.
응, 그거는 되죠. 예비 출고라고 하고.
그리고 이런 경우도 있어요. 그러니까 쓰다 보니까 재고 조사를 해야 돼요. 재고 조사를. 근데 이제 창고 재고하고 실제 재고가 안 맞는 경우가 생기고 이러는 경우가 생겨요. 그래서 건강상으로 맞추려고 그러니까 얘를 옮겨야 되는데 옮겨서 숫자를 변경해야 되고 이런 경우도 있더라고요. 그래서 그걸 할 때는 예를 들면 한 개 갖고 왔다 물론 시간이 많으면 할 수 있겠지만 양이 많아지면 그 계속 일을 해야 짧은 시간에 하려고 그러면 연동으로 돼서 움직임이 맞지 않나 했다는 여쭤보는 그런 느낌이 있는데
제어 쪽으로는 문제가 안 될 것 같고요.
어차피 뭐 이론상으로는 안 될 게 없어요.
그러니까 이게 팀장님 말씀은 얘네가 일하고 있는데 한 놈을 지정을 해서 내가 피난번 물고만 꺼내고 싶다는 말씀이시죠?
이제 그렇게도 쓰고 필요하다 그러면 해가지고 아까 얘기한 대로 특정 셀에 특정 지정된 셀에 갖다만 놔야 되는데 그 작용만 해. 원래는 한 층에 한 개만 쓸 건데 이게 이제 급하니까 두 개, 세 개를 돌린다 치면 한 개는 계속 갖다만 놓고 나머지 두 개가 이제 거기 셀에 맞게끔 지정된 벽에 맞게끔 집어 넣는 거지.
근데 만약에 수동이든 자동이든 뭐 1층에 있는 물건들이 출고가 많아진다면 어차피 셔틀들이 타고 내려와서 1층에 같이
아니 그 층에서 움직일 수도 있고 내가 얘기하는 거는 그 층에서 예를 들면 1번 셀에 있는 게 저쪽 끝에 100번 셀에 갖다 둔다든지 그러면 1번 셀을 빼서 밑에 층에 5번 셀에 갖다 둔다 이런 경우도 있을 수 있어요.
근데 어차피 메인 터널에서 셔틀 제일 속도가 빠르기 때문에 한놈 그냥 끝까지 오는 게 더 빠를 것 같아요.
Okay, thank you for waiting. We just focus on the basic layout. So, about the side view, we can find this model. For usage, we just can find that the distance of this pallet. This one is the height and this one is the width. So we can change it maybe into 1,000 and 100 millimeters. It is easily to change. And if we want to do the side view, maybe we can check the height of our pallet. This height is including the pallet and our measurements. Maybe 1,900. Then we can find this type is different from the basic one, so we just delay our height. And in this situation, we need to move our forward shuttle and the rack system from the middle to the middle.
말할 수 있는 게 이제 지금
Sorry.
아니 이거 이거
Then we can find we need to move our rack system again to the line. Then we copy the ground level and for maybe we can check the distance between the top of our mesh to the rack system is 200 is too large for us. We just keep the rack system up to the red line. So basically on the hole of the hole on the rack system, we just move it. And basically we need to input our sprinkler. on each two levels. So the next level.
이거 설계자가 아니신가?
Is about 500 won and 10 millimeters. That means in this space we can input our sprinkler. That's our basic.
아, 저건 최소 높이고 요거는 예, 스프링클러가는 강구가 높이 얘기하는 거 아니에요?
Okay, and our hoist, the height of our hoist is easily changed. Just link this one to the top of our roof. Then we can get the height of our hoist.
응?
Let's go back to our PowerPoint. Then we need to, when we get the height of our hoist, we can calculate the efficiency of our hoist. So first of all, we can find that this orange part of our picture needs to change the data, and no other changes are needed. First, take a look at this part, which is filled in the form based on traffic data in the demand server. The return and the transfer volume in the table includes both return and cross-level transfer within the warehouse. So the measuring factor is considered to be received based on customers' requirements. And from this part, we can find that this is the basic speed of our lifting platform in the lifting system. So, so we can change this those numbers only if we change the type of our hoist. And this part of our picture will have two situations. In one case, there is a connecting conveyor in the warehouse. The material is conveyed through the conveyor to the inside of the hoist. And the four-way shuttle handling time is changed to 0. But in this situation, there is no connection conveyor in the warehouse. That means this material is transported to the hoist by a four-way shuttle. This four-way shuttle will go through the levels with the platform. So that means this number goes to 0, and we keep this number. So I will show you about. Okay, this is the calculation form for our hoist. I think all you already get this form, so maybe we can have a quickly. We can have a quickly calculate our efficiency of our hoist. First, we can find there are 3 important points in the hoist. The O is our first level of the pallet, and T2 is the top level of the hoist, and the P1 is two-thirds height of the P2. So seem like from this picture we can find if the pallet height is almost 14 meter, and the P2 may equal to 12 meter. So we can calculate the efficiency. Maybe we can just choose a different type of docking. If our hoist without the conveyor, so we just delay the conveyor time, so we can get the efficiency. It's almost 32 pallets per hour. And if we don't need a forward shuttle to do the transport work, we just keep this number and delete the forward shuttle vehicle transport time. So the conveyor efficiency can get 36.96 pallets per hour. So do you guys have any question about this calculation form?
뭐 설명 다시 한번 해주세요.
能再详细讲一下吗？
아, 영어로요. 막 묵지가 않은데.
能再详细啊？
文件有发吗？
什么文件？
就是这个文件。
有，我们都有。
这不都打印出来？
没有。
还有那个都是有。
是抄一下。电脑上有没有？
电脑上有啊。실제 한번 그 프로그램을 한번 써보라는데요. 파일 안에 그 시트가 있거든요. 네.
就是现在是详细讲的是
详细。你看这英语我也翻译不了啊。이해가 되셨나요?
这个。
可能会耽误别人的，不然你帮我讲一下，我来翻译给他。就这个流程，就这个计算公式，计算方式。
计算方式就是目前就让徐川先过一遍，然后下午会再做一个。
그러면 제가 시간 내 가지고 단독으로 제가 이분 통해서 한번 설명드리겠습니다. 네.
看时间不大够。
이사님 다 해봤잖아.
맨날 헷갈려. 전당내기 바쁘지. 앉아갖고 맞춰보고 잘 헷갈려.
老出现那个图片。
Okay, I think the problem is many of us don't know the difference between those two types. So basically, we have a conveyor to link the rack to our hoist. That means when the foil shuttle goes through the air and our foil shuttle can put the pallet at this conveyor. Then the foil shuttle can lift to other work. But in this situation, we don't have a conveyor in the rack system. That means our foil shuttle need to transport the pallet through the lift. So, for example, if we need a pallet transport from the 6th level to 1st level, that means in this situation, our foil shuttle just put the pallet at the conveyor and the shuttle can leave. And our hoist just get the pallet and transport it, lift it to the 1st level. But in this situation, our foil shuttle need to take the pallet and go into the hoist, and the foil shuttle need to transport the pallet to 1st level, and the foil shuttle will go to the 1st level. That's the difference in efficiency.
아, 이거 그림만 봐도 바로 이해된다.
그러니까 우리가 셔틀을 인터페이스할 때 컨베이어를 인터페이스할 때 시간 차이도 위에 두 개가 그러면 셔틀일 때는 13초가 걸리는 거고 컨베이어일 때는 9초 대입을 해서
그렇죠. 셔틀이 리프트까지 들어가야 되는 거고 얘는 그냥 컨베어까지만 갖다 주면 되는 거니까 그거 방금 트로트에서 빈서 전문이 꽂아놓고 저렇게 돼 있는 거냐. 왜 안 되지?
보낼 거야.
저 예전에 들은 거에 한국말 잘알수 있죠.
第一个，自重机输送耗时，4厢车搬运耗时。
就是一个有接驳位输送线，一个没有接驳位。
这三者的关系是怎么？有公式上面有计算公式还是？
你说哪个三者？
就输送机输送耗时，4厢车搬运耗时，时间加动力。
输送机和输送耗时和4厢车搬运耗时两个只要用一个。
是手动填进去的是吗？
这个是一开始会给一个值，但是在我们场景选择的时候，如果它没有输送线，我们就需要把输送线耗时删掉；如果它有输送线，我们就把4辆车搬运耗时删掉。就两个有一个值需要是保持是0。
이게 리프트 나올 때 그 컨베어가 있을 경우는 첫 번째 뼈 컨베어 소요 시간을 입력을 하는 거고.
컨베어도 앞에 앞단에 컨베어가 있을 경우에 도출하는 시간.
예, 그러면은 퍼의 셔틀 뭐 운반 시간은 삭제해야 됩니다. 둘 중에 하나입니다.
그렇죠. 둘 중에 하나만 하는 거죠. 저게 이제 컨베어를 쓰냐 아니면
셔틀이
셔틀만
들어가냐.
쓰냐 이거 차이죠. 그러니까 둘 중에 한 칸만 넣어야 되는 거죠.
그렇죠.
여기 그러면 왕복이 아니라 편도예요. 편도.
它是往返的耗时，还是说只是说过去的耗时？
你可以理解为，第一个是4厢车把托盘放在输送线上面，然后4厢车直接走掉，那提升机做的工作
那是往返的耗时吗？
不，就是提升机直接从输送线上面取一个托盘的时间。然后第二种情况是提升机到这一层之后，它需要等待4厢车进入提升机的时间。对，这两个区别。
편도죠. 편도.
그러니까 저 이제 그 앞에 있는 컨베어까지 가는 시간이
들어가는 시간.
뭐 앞장까지 막 잠깐만.
저 나온 리프트에서 나오고 와서 저기까지 가는 시간. 이제
이제
셔틀은 업다운 시간이 플러스해야 되는 거니까. 가서 업하고. 다음에.
Let's take a
중국어로
look.
기억하고.
Let's take a look at this
저분이
phone.
하시는 영어가.
First, the orientation of the hoist must be from the direction of the air cargo positioning to enter the hoist. That means our foreshadow just can go into our hoist in the sub end.
다른 분들과 본 적.
Then, how is the length of the conveyor of the transfer machine section determined? The length of the goods is within, for example, 1,200 millimeter, and the length of the transfer machine is about 2.4 meter, and beyond 1.2 meter. Does the transfer machine is to increase accordingly? So I think then the length of the transfer position conveyor, the length of the transfer conveyor within 1.2 meter of cargo length. So the transfer conveyor is about 1.5 meter, and beyond the 1.2 meter, the transfer conveyor needs to be increased accordingly. At the same time, I think the length of the conveyor inside the hoist is equally the length of the connection conveyor. So we can find that the hoist size in this mapping learning environment, the pallet inside the hoist goes wider, and the hoist goes wider. So it all depends on the size of our pallet. Basically, we can find that the distance between two pallets is 75 millimeter, and the distance between our pallet and the rack is 75 millimeter. So, any question about this distance? 75 millimeter. 75 millimeter is our standard size, but we can reduce this distance to 50 millimeter. Is also enough for us. This is our script planar driving. We can find that we just change the size of the pallet location and block air. Then the last time is that we can do the driving. Maybe we can have